Hello, this is question 27 from the 2024 Matt. The faces of a cube are painted either red or blue. An ant is positioned on each of the 8 corners of the cube. Each ant can only see the 3 faces that meet at the corner of the cube. Right. In this question, the ants will be asked about the faces they can see, and the ants will always answer truthfully. These are clever ants. Part 1. The ants are each asked, can you see an even number of red faces? Each ant answers either yes or no. Explain what a number of ants that say yes is even. I wonder if anyone said ants can't speak, so it'll always be 0. But assuming ants can speak then. So can you see an even number of faces? Each ant either answers yes or no. Right, okay, there's no obvious way that I can think of to jump into this one. So can we do a trial and error approach? I mean, what are the number of options that we've got? I'm not happy with this necessarily, but it's the way that is presenting itself to me when I can't think of a better way at the moment. So how many red faces could we have then? So if we had no red faces, then obviously each ant is going to answer yes, because 0 is even. So we're going to get, so if we've got 0, so let's do a little table then. So let's say we've got, that's our number of red faces, and this would be our number of yes answers. So if we've got no red faces, we're going to get 8 answers. If we've got, well, we've got lots of options here. 1, 2, 3, 4, 5, or 6. So if there's 6, then it's going to say, can you see an even number of red faces? Well, each one of them is going to see 3. So we're going to get no answers on that. Then for 5, so that means we've got 1 blue face. So there's going to be 4 ants are going to be looking at a blue face and 2 red faces. So we're going to get 4 answers there. Maybe this is going to work okay. If we got 1 red face, we're going to have the same thing. If we got 1 red face, can you see an even number of red faces? It's only going to be the ones that can't see that face at all, which will be 4 of them, who are going to get a yes answer. So if we've got 2 red faces, the trouble with 2 red faces is they could be 2 red faces that are opposite each other, i.e. they're not connected, or 2 red faces that are next to each other. So that splits out into 2 options. So as in whether they're opposite or whether they are adjacent. So if they were adjacent to each other, well, actually opposite is going to be easier. If they're opposite, then each ant will be next to 1 red face. So they're going to say, we're all going to say no. So that would be 0 for opposite. If they're adjacent, so adjacent faces, that means we'd have 2 ants that would be next to both of those faces, 2 ants which are next to neither of those faces. So we'd have 4 answers if they were adjacent. Okay, right, we must have a similar thing then for 4 red faces, because we'd have 2 blue faces. So if we had 2 blue faces, we'd have 2 ants that are next to both of those blue faces, so they would answer no. We'd have 2 ants which are only next to red faces, so they would answer no. So we'd end up with 4 saying yes again. Okay, so opposite and adjacent. So if they're adjacent, we're getting 4 again. And if we've got them opposite, then each ant will be next to 2 blue faces. No, 2 red faces, I mean, and 1 blue face. So they're all going to say yes if they're opposite. Okay, right, this is going okay. And then what if we've got 3? So if we've got 3 faces that are red, how can we arrange those? We can cluster them all round 1 corner, as in say it's half the cube, or we can do them in a line. That's all we can do, really, isn't it? So we've got, for 3 of them, we've either got a line of red faces, or we've got a corner of red faces. So if it was a corner of red faces, you'd have that one ant would be looking at all red faces. You'd have one ant that's looking at all blue faces. And then all of the others, would they all be looking at two then? Trying to think. If it was all on the corner, so if this one, so those two sides, well, the bottom, the side that's facing us and the side to the left, if they were all red, then that one would see all red. This one's next to 2. That one's next to, oh, that's just next to 1, isn't it? That would be next to 1. That would be next to 1. That would be next to 2. That would be next to 2. That would be next to none, and that would be next to 1. So we've got 4 of them. If it's the corner. Okay, and then if they're in a line, then what happens if they're in a line? Then boom, boom, boom. You're not going to get any of them who are getting next to all 3 of them. You're going to have 4 of them are just going to be next to 1, and 4 of them are going to be next to 2. That's going to be the case on that. So we're going to get 4 again. I don't like this. I want a different solution. I mean, that seems to have worked, but I'm not entirely convinced that I haven't made a mistake in working out how many there are of each one. So there must be a better way of doing it than this. So what else could we say? So each what if we think about each face? Let's try a different option on this. So each face is visible to 4 ants. So that's one thing that we know. So what does that mean? I don't know what that means at the moment, but that's one thing that we know. Each face is looked at by 4 ants. Let's see if we can put these things together. Then if they say yes, if you've got an ant that says yes, then that means they're seeing an even number of reds, even number of red faces. And no means an odd number of red faces. Okay, and we've got 8 ants. So that's all the information that we've got on this. So why does that necessarily mean that the number of ants that say yes is even? So each face is visible to 4 ants. So we're getting an assessment of 4 times the number of red faces. And so that's even. And we got an even number of faces all in all. Yeah, it's got to add up. These have got to end up being even, haven't they? This total here has got to end up being even, because we're giving an indication of how many red faces there are. So how do I turn that into words? Yeah, okay, this is a better way of going about it. I'm much happier with this. I just don't know how to actually put it in words to give an answer. So the 4 times 6 equals 24 assessments of colour of faces. Okay, or we could say it's 3 times 8. It's the same thing, because you've got 8 ants looking at 3 faces, or you've got 6 faces looked at by 4 ants. So either way, we end up with 24 assessments of the colour of the faces. So each yes gives an even number of red faces. Each no gives odd number of red faces. So we have to have that the total, these need to total 24. Therefore, must be an odd number of, no, not an odd number of no's. It must be an even number of no's. Even, actually write the words you're saying. Even number of no's. Therefore, even number of yeses. Because if we're taking an even number off of 8, then we must have an even number. Right, okay, that is a much better way, I think, of doing it than running through those, what is it? There's quite a lot of different options that we've got here. So that's 7, 8, 9, 10 different permutations, which I might have got right, but I'm not 100% convinced, as I say, about the numbers in the yes column there, whereas I am convinced with what I've written out in blue. But that is a tough start to the question. Right, let's get a blank sheet up then and carry on with this. Hopefully it gets easier than that if you have to do all that for 3 marks. Is it possible that all 8 of the ants can see exactly 2 red faces? Yeah, I had that. I've just spoken about that when I was going through those permutations. That was when we had opposite blue faces. Because if it's opposite blue faces, each ant is looking at one blue face. So that's handy that it did fall out of the first method of doing the first part. So if there are 2 blue faces opposite each other, then each ant will see 1 blue and 2 red faces. Therefore, yes. Okay, that was much easier for 2 marks than the other one was for 3. The ants at each ask, can you see at least 1 red face? Explain why it's impossible for exactly 5 of the ants to say yes and 3 to say no. Right, 3 to say no. So if we've got, well, we know, can you see at least 1 red face? So for an answer of no, this seems to be the way in, because we know an answer of no. If they're saying it's all blue, like you're taking this ant here, then all 3 of those sides coming off of that corner must be blue. Of no means 3 blue sides at a corner. And then we've got 3 of them saying no. There, so 3 no's means at least 5 blue sides. Because if we've got 3 of them coming off of that corner being blue, and then we go over here, well, we have to have 3 of them off of there. Okay, 2 of them could be the same as off of the other one, but we must be adding in a new face. So that would make then 4 sides. And then we'd have to go to another corner and make it 5 sides. So we've then got, therefore, 1 red side at most. Therefore, at most, 4 ants alongside, well, at the corners of that 1 red side. Okay, that one was fine as well. Part 4. Suppose that the 4 ants on the corners of the top face of the cube can see exactly 0, 1, 1 and 2 red faces each in some order. How many blue faces might there be in total? Find all possibilities and explain your answer. Okay, so on this picture, so we're saying we've got 0, 1, 1 and 2 red faces. So if we got 0, then we know we've got 4 blue sides coming off of it. So that would make Okay, so let's take this one. I'll stay in blue. So let's take this one here in that corner. So that would mean that the top side, the side that's off to the left here, and the side that's facing us would all be blue. Okay, so that's half the cube. So if we've got a 1 and a 1, let's see exactly 1, 1 and 2 red face. Well, 2 red faces, 1, 1. So this one over here, and we already know that 2 of the sides coming off of it, so the top and the one on the left are blue. And the same with, oh yeah, okay, we're going all off of, oh, and the same with this one. So these were both, if that's the 0, that has to be the 1, and that has to be the 1. Because, yeah, they've already got those blue sides. Okay. So that means that the side, we don't know anything about the bottom, but we do know that this side here and the back, so the back and the side on the right would have to be red. Okay, right, so let's put all these in then. So for the 0 corner, all 3 sides are blue. Right, so we've got that. Therefore, the corners next to the 0 corner must be 1s because they already must have 2 blue sides. Therefore, the final corner is a 2 and has the 2 red sides required by the 1s. Okay. We know nothing of the bottom side. Nothing of the bottom side. Therefore, that means we're going to have 3 or 4 blue faces. 3 or 4 blue faces. Because we just don't know what's happening at the bottom. It doesn't affect anything what's happening on that bottom side for the ants that are on the corners of the top face. So it's got to be one or t'other, depending on, well, what we've got down there. Right, last part. A 3-dimensional shape is constructed such that each face is either a square or a hexagon, 2 faces meeting at each edge, and 3 faces meeting at each corner. That's what we just had with the cube. Each face of the shape is painted either red or blue. Okay, consider the edges where a red face meets a blue face. Explain why the number of such edges is even. Okay. Right, so what's hexagons got to do with any of this? If they're meeting, yeah, I'm not really sure. Does it make any difference? I mean, have we done this in the previous part? Because we've just been talking about the number of red faces they can see. I haven't said anything about the edges, so that's a bit different. But we've still got that similarity that, you know, here for this cube, we have got every edge is just 2 faces meeting, and every corner does have 3 faces going in. So that is exactly the same. That's quite noticeable that we've got here. So if we've got a corner, then it's split like that. That's what we've got every time. How do we consider the edges where a red face meets a blue face? Explain why the number of such edges is even. Does that mean it actually wants us to, is that a hint? Consider the edges. Is it hinting at us to look at those edges? Or is it just setting up, well, they're the things that we're looking at? Not really sure where to go with this one. Each face of the shape is red or blue. So, I mean, if we do put two edges together, so if you put a square and a square, so say they were the same color, we started off with 4 edges, and then we're going to go to 6 edges, or if we put a hexagon next to it, we'll be going to 8 edges. I'm really sure that's going to help. But they're all meeting here at corners. I wonder if this is going to be a better way to look at it, looking at these corners. I mean, what could we have on a corner? There seems like fewer permutations. There's a lot of permutations looking at edges, because we've got 4 edges on a square, 6 edges on a hexagon, and then how do you actually turn it into a shape? Whereas corners are, yeah, they're more finite. I mean, we could have, so say we had blue, blue, blue. That's one corner that we could have. We could have blue, blue, red. We could have another corner which is then blue, red, red. And we could have another corner which is red, red, red. So we've got, that's the only permutations we've got. So we've got 4 possible types or configurations of corner. Okay, so, and then we're looking at the number of red, blue edges. So for so we've got blue, blue, blue. That gives us 0 red, blue edges. Yeah, this is going to work fine, isn't it? Yeah, let's do it like this. So blue, blue, red will give us 2 blue, red edges. Or red, blue edges, as I started calling them red, blue. Then we've got blue, red, red gives us 2 red, blue edges. And red, red, red gives us no red, blue edges. So therefore, total red, blue edges must be a multiple of 2. Okay, that worked out fine. I thought it was going to maybe follow on that we'd have to do more stuff with ants, but it just seems really complicated putting hexagons in. Although I suppose they're still doing exactly the same thing, but then how do you know how many ants there are if you don't know what the shape is? I think this corner thing is the way to go. I like that. That's dropped out quite nicely. So that was a tough question. The first part in particular was, I thought, very difficult for 3 marks, this part 1. Okay, it did get easier then in 2, 3, 4. Okay, 5 wasn't easy. I wouldn't say that was easy. It drops out nicely with the corner approach. But yeah, I'd say overall that was quite a tough question. 2, 3, 4 wasn't so bad for picking up maybe 8 marks there, but the other 7 marks, that first part I thought was quite unpleasant to be sure of. Although I suppose there is the thing with that first part that, I mean, maybe for part 1, this table here, I don't know, maybe I've got that correct with the permutations in there, you know, or it might have got 2 marks if I've made a mistake or something like that. So it wasn't a complete disaster. Like there was no way of finding a foothold in the question. But the blue explanation I think was certainly better. But overall, I would say that was quite tough.